Okay, I'm going to do a quick little video here about the Triangle Inequality Theorem. The idea here is, well, we'll just start with a triangle. So we have a triangle. Okay, but now let's imagine we only have two sides of this triangle. So we actually have two sides. And these sides are lengths 4 and 7. So the idea here is that if I drew this third side, I didn't do a very good job of that drawing right there. But how long is that side? Now, since we can't guarantee if it's a right triangle, if I said it was a right triangle, we could use Pythagorean theorem, but it could be any kind of triangle. So the idea here is that it could be a lot of different lengths, but it can't be every length. For example, one idea is it couldn't be, say, 100. So could this equal 100? And I'm going to say no, it can't equal 100. And the reason is why? Well, let's imagine that we have a little hinge right here. Okay, so that can open and close. So I have a 4, then I have a hinge, and then this 7, and it's going to open up. Okay, and eventually we can swing it to where it's perfectly straight to make a 180-degree angle. So now I have an angle here that is, there's a 7. And we have a 180-degree angle, so it's a perfect straight line now. Okay, that line is only how long? This line's only 11, right? It's only 4 plus 7 long. So I can't put 100 here because once this opens up, the widest it's ever going to be is 11. Okay, that kind of makes sense here. So it can't be 11 because if I took this side, let's say I took a side here, and I'll make this side blue again. So this side's going to be exactly 11. Well, that's not really going to make a triangle because when I attach it to these sides, it's just going to be a straight line on top of a straight line. Okay, but now let's imagine that I have one that is 10. So I'll draw a line here that is 10. I can take this, again, this is hinged. I can take this spot, move it to there, and I can swing this up and move it to there. And what would happen is really wide, probably be even wider than that. And then make a triangle. So the triangle inequality theorem basically says, there's two parts of it here. The first part is if you have two sides, it can't be bigger than those two sides added together. So the third side, let's go ahead and erase this for a second. Okay, we'll start over here. So let's go ahead and let's say we have, go back to our 4 and our 7. The longest that this third side could be the longest is equal to, it's actually not equal to 11, but it's less than 11. So the longest is less than 11. Okay, so now let's take the same idea, and hopefully everybody kind of gets that. You can have 10.9, it's going to be a really flat triangle. If that's 10.9, it'd be like 10.9, can't even draw it, that's flat. Something like that. but it would make a triangle. But once you hit 11, it can't be a triangle. It'd be too straight of an angle there. Okay, so now let's think about what happens if you took this 4 and the 7, again, I'm putting a hinge right here on that angle. And this time we close this angle all the way. Well, imagine this. I swing it virtually all the way closed. And when you close it all the way, what's that overlap? It's going to overlap, looks like about from here to here. And the length of that overlap would be 7 minus 4, or 3. So what that means is that the smallest that could be, if you're a third side, if I wanted to make my third side, so if I want to make my third side here, like that somehow, my triangle, that can't be 3, because if it's 3, the 3 plus the 4 equals a 7. It's going to be a straight line. So it has to be bigger than 3. So like maybe this time it will be like 3.2. I'll just make up there. So the shortest it could be is greater than 3. So if the shortest it could be, I'm going to call this third side X. Third side X. The shortest it could be is 3. The longest it could be is 11. So that means that that third side, call it the third side also, has to be between 3 and 11. Can't be bigger than 11, can't be smaller than 3. Everywhere in between works. So now let's look at some ideas or some problems. These first types of problems says state if the 3 numbers can actually make a triangle. So the best way I think to show this would be to say, well, let's look at one that won't work. So like number 2, I'll just tell you right now, will not work because this 2 side and the 3 side, and then you're going to have a 6 side. And there's no way that I can connect these to make the triangle. So this would be a no. Now the quick way is to check the 2 smallest numbers, and they have to add to more than the third number. So if we were doing this mathematically, you would say, is 2 plus 3, is that greater than 6? And your answer is no. The 2 smallest sides have to add to more than the third side. Here, the 2 smallest sides, does 4 plus 5, is that greater than 7? Yes. Is this is number 4. Is 2 and then 8 and 8 are both the next smallest. 2 plus 8, is that greater than 8? Yes. So that's what you're looking for. The 2 smallest numbers have to be bigger than the third number for it to be a triangle. Okay, now for the next part of it, what we did on the last slide here, is that we're going to check, and I'll just imagine, again, 5, we have a hinge here, and a 9. So the biggest it could possibly be, if you made that straight, would be 14. And if you straighten it out, it'd be 14. If you went this way, it'd overlap 4. 9 minus 5 is 4. So the third side has to be bigger than 4, but has to be smaller than 14. So again, the quick way is you just go 5 plus 8 is 13. That's the big side. 8 minus 5 equals 3. That's the small side. The third side has to be between 3 and 13. And you can use an x there if you want. All right, quick triangle inequality theorem.